So now that we know the basics of perspective projection, like you are familiar with the terms station point, picture plane, object, then what, central plane, horizon plane, etc. We'll try to attempt a question. Okay, the question is very simple. It's a square prism, 30 mm base edge and axis 50 mm long, resting on the ground on its base, such that one of the base edge is parallel to and 10 mm behind the picture plane. So it's resting on the ground on its base, and one of the base edge is, let's say this is the picture plane, it's parallel to, one of the base edge is parallel to and 10 mm behind it, behind the picture plane, right? Now the station point, we will continue the reading the question. The station point is 60 mm in front of the picture plane and 70 mm above the ground. Okay, 60 mm in front of the picture plane and 70 mm above the ground. The central plane passes through a point on the picture plane which is 60 mm towards the left from the center of the prism. Now this the questions generally of perspective projection are a bit lengthy, but when you read the question, you just focus your attention on two things. First thing, we need to locate the solid with respect to the picture plane. Okay, we need to visualize, we need to imagine the position of the solid with respect to the picture plane. That we need to figure out while reading this. Second thing is we need to locate the station point. So the station point is 60 mm in front of the picture plane and 70 mm over the ground, but we don't know exactly where exactly is the station point. How do you find out? With the help of central plane. We know the central plane is a plane which is perpendicular to the picture plane, but it can pass through any point on the picture plane. It can be like this. But in the question, if you read carefully, you can figure out central plane passes through a point on the picture plane which is 60 mm towards the left from the center of the prism. So if this is the center of the prism, 60 mm from here towards left, this side, passes your central plane. Okay, central plane. So what is the good thing of locating the central plane? You know the central plane, the station point always passes, or central plane is a plane which passes along the station point. So suppose this is your station point, the central plane passes like this, right? So this is your station point, 60 mm. Now this is your central plane and your station point is 60 mm in front of the picture plane. So this distance is 60 mm, 70 mm above the ground, 70 mm above the ground. Okay, from here take 70 mm above. From this point you look at this object. So I'll show you the setup using a better model and then we'll come back. So as you can see, the light blue book is your ground plane. Okay, that's a ground. You can see this square prism resting on the ground on its base, and you can see the picture plane. Right now we are viewing from the observer side or from the station point side. So this is the top view. You can see the square prism, the square shape. When you look from the top, since it's resting on its base, when you look from the top you see the base as a square, and then you can see this edge of the picture plane also. You can see the edge of the picture plane also. So we need to locate the central plane. Okay, so in the top view, from the center, the central plane is supposed to pass through a point on the picture plane which is 60 mm towards the left. Okay, towards the left side. This is your left side. From this point the central plane passes. The central plane actually goes like this, so when you look from the top, what you see is a square, the picture plane and the central plane. From the center take 60 mm, from here 60 mm in front. So let's say get somewhere here. And not only that, it's not resting on the ground. The station point is not on the ground. It's 70 mm above the ground. So here from here 70 mm above. From this point from this point, when you view the solid, what do you see? The screen. So this is your station point. When you look from here, you can see the red line in the screen, and that's your image. Okay. So you can see the image formed on the screen when you look from the station point. Okay. So the station point is, this is center. From the center, it takes 60 mm towards the left, and from the picture plane, 60 mm in front of the picture plane, and then 70 mm above from the ground. Okay, from this point 70 mm above the ground, you look the object, and you can see the image formed on the screen. To show you image, I'm just removing the object, and that's exactly what you need to draw, that image on the screen. That's what we are going to do. Okay, so now you know the position of the solid and from which point you are viewing the solid. So the first step is to complete the top view of this setup. Okay, so when you read the question, you need to imagine in your inner mind the position of the solid with respect to the picture plane and the point from which you look the object. Okay, this setup we have to imagine, and then you have to draw the top view of the setup. So this is exactly what you need to imagine in your mind. Okay, the top view of the setup, object, picture plane, and the station point. So when you look from the top, this is what you get. See the picture plane as the edge of the picture plane, and 10 mm behind, you measure 10 mm behind, you have the square, the space edge parallel to the picture plane. Locate the center of the prism to find out the center plane. From here, take 60 mm, draw a line which is perpendicular to the picture plane. From this point, you measure again 60 mm, because it is given the station point is 60 mm in front of the picture plane. So this is the picture plane in front of the picture plane, this is your station point. Okay, so we have the top view of the whole setup. See the top view of the whole setup. Now view the object. Okay, the next thing is view the object, and before that you need to name the points. So I'm going to name this as A, B, C, D, the top points. Okay, A, B, C, D. Bottom points A1, B1, C1, D1. A1, B1, C1 and D1. Right? Then I'm going to draw visual rays from SP to each and every points. Okay? I'm going to make a fair drawing just to show you what exactly happens. So when you draw the visual ray, you can see that the visual ray hits the picture plane at these points. Okay, if I suppose I have drawn a line from SP to B1 point, I can see that while I am drawing that line, it hits the picture plane at this point. This is called a piercing point. Piercing point. How do you obtain a piercing point? When you draw a visual ray from station point to one of the base corners or edges, you intersect the picture plane, and that point of intersection is called a piercing point. So B and B1 are the same point, so B comma B1. This is my piercing point for B and B. Why I am naming this? Do you have any idea? Because this is where my image is formed. See, when you look at this object from this point, okay, 70 mm above, the image is formed here. Why you can't see this image? Because we are looking from the top. To see the image, you have to change your view and you have to look at the front view. So the next step is, so this completes your first step. First step is drawing the top view with respect to the picture plane, finding out the station point. How do you find out the station point? Locate the central plane and then take so much distance in front of picture plane, you get the center station point. From the station point, you view the object and you locate the piercing points. Very simple. The second part is nothing but drawing the front view of the setup. Okay, right now what we are drawing is, I drawn the top view of the setup. Now we have to draw the front view of the setup. I'll explain after drawing the first part. Center of the prism. From here, take 60 mm towards the left to locate the center plane. Okay, from the center, 60 mm towards left, and from the picture plane, 60 mm in front. Name the points, each and every corner. Draw the visual rays, and you can see the piercing point right here. And name the piercing points also. So that completes your first step. So the second step, I'm going to directly do it here. Second step is drawing the front view of the setup. Okay, so what I'm going to draw is, so when you look from the front, so this is my setup. So when you look from the front, what you see is a rectangle. See the front view, orthographic front view, not perspective view, the front view. So you see a rectangle in the front, and you see the station point 70 mm above the ground. Okay. So basically you can draw the ground line anywhere possible. So comfortably below. So after drawing the ground line, you have to locate the horizon line. Horizon line is 70 mm above, and there exactly you have the station point. So I've drawn this. So that's your HL. And to locate the station point, you need to draw a perpendicular from the SP to locate SP dash. So that's your station point in the front view. So repeat that once again. So basically what you do is, you draw the ground line, take 70 mm above, your station point is 70 mm above, and that is exactly your horizon line. Mind you, horizon line is the line obtained, or in this line lies your station point. So you have to mark it as HL, that's important. And after that, you already have your station point here. Drop a perpendicular to the horizon line to get SP dash. Okay, and you make sure your SP and SP dash is in the same projector line. So once you have SP dash, when you look from the front, you see the rectangle. Okay, so you draw the rectangle. So from here, you drop a projector like this. Then what is the height of the 50 mm, right? So which is this point? Can you tell me which is this point? How do you find out that? Just traverse along your projector line and you find B1 and C1. Which is this one? B or B1? See, this is B and this is B1. So when you look from the front, you see B1 edge first, and behind that you have C and C1. So first you see B1 edge and A1 edge, and behind B1 you have C1, behind A1 you have D1. Okay, so this is A dash, B dash, C dash at the back, D dash at the back. That's the top base. Below you have A1 dash, B1 dash, C1 dash in brackets and D1 dash in brackets, both at the hidden side. Okay, once you have that, the other thing, what you have done here is, after locating the station point, you draw visual rays. Here also you do the same. Okay, draw visual rays. Mind you, when you draw the visual rays, you draw it in a very thin line. Here, the video, it's very hard to show the thin line because it may not be visible. so I don't have a choice. But when you make the drawing, make sure that you draw it as a thin line. Okay, so that is your front view of the setup. Now after this, the last part is very important, so I'm going to use another color for that. So last part is very important. You have these piercing points here. So let's say I'm going to locate A1. Okay, to locate the perspective projection point of A and A1, all you have to do is from the piercing point of A and A1, from this piercing point, you drop a projector until you get to this visual ray drawn to A dash and A1 dash. See, the visual ray from SP dash to A dash is this. The visual ray from SP dash to A1 dash is this. So from the piercing point, drop a projector and we get to A1, A dash and A1 dash. So that is your A, perspective projection point A, and this one is A1. Okay. Similarly, B and B1. This is B, this is B1. Okay, and then C and C1. And lastly, D and D1. This is SP dash to D1, SP dash to D. So this is D and this is D. Oh God. D and D1. Okay. Right. Now what I'm going to do is I have to connect these points. I have located the perspective points. Now I have to connect it. How do you connect it? First, you have to connect the visible edges. Now, how do you know which is the visible edge? See, your view is here. Mind you, I guess you remember the trick I have, the shortcut I have given you during I have explained the orthographic projection topics. So the way you look using a torch, when you light up a torch, where does the light goes? That is a visible side and things like that. See, this is your torch. When you light up the torch, your light goes in this direction and falls in this side. Okay, so this is your visible side. So visible side is A1, B1 and D1. So you can connect those points. So A1, B1. There's a small error in what I've drawn. Normally this should be parallel. Parallel to the ground line, because it's parallel to this. But since your ground line is slightly inclined, there is a small error here. Let's see. So D1, connecting D1 and A1, because that is also visible. You can see this edge A to D and below A1 to D1. See, you can see this face and this face. This is A, B, A1, B1 face, and A, D, and A1, D1, A1, D1 face. So now that we connect this one, the height of this is how much? The height is 50 mm, and the station point is 70 mm above the ground. See, this is 50 mm and the height is 70 mm. So obviously you're looking from a point which is higher than this point. And what does that imply? It implies that you can see the top face. Okay, because you are viewing the object from a top point, from a point which is higher than this maximum height. So this length is 50 mm, whereas the station point is 70 mm above. So in short, you can see this top face. We connect the top face, which is that is have a word of caution that may not be the case. You have to be very careful. If suppose the distance from the ground to the station point is say 40 mm, 40 mm from 40 mm, which is less than 50 mm, when you look at this object, you may not see the top face. So you have to always pay attention on the location of the station point. In this case, you can see it. See? So that's our answer. So this is very much similar to the image that we saw in the picture plane screen and the model I have shown you. So how about the hidden edges? So when you look from here, this is your hidden edge. Okay, C and C1. You are very sure your light doesn't fall in that part. Okay, the C1 part. C1 part. Your light doesn't fall at C and C1 when you look from here. So C and C1 are hidden. So C1, you have to draw it as a dotted line. So C1 is hidden, so obviously C1 D1. If a corner is hidden, the edges connecting those corners will also be hidden. That completes your drawing. This is the answer. Now let's just take a minute to study this thing. So you can see these edges, A to D and A1 to D1. These edges, A to D and A1 to D1. Those are actually parallel edges. See, those are parallel edges, these two edges. But in this perspective projection, they appear to meet here. Okay, and also you can see the same is true for BC. And BC is this one, AD is this one. All of these edges are parallel edges which actually goes and hits to this SP dash. So it appears to converge at one point. These all parallel edges converge to one point. So this kind of perspective is called single point perspective. Whereas if you have a perspective projection in which you have more than one converging point, we'll see that later in the coming questions. If you have 2 points instead of single point convergence, you have 2 points convergence. It's called 2-point perspective. Okay, so that's just, we'll see that in detail. I want you to try this question.